Okay, so I think there are still a few people joining, but we'll already start. So welcome to this webinar on Microsoft Cloud PKI. Today we will look at a cloud-based service that simplifies and automates certificate lifecycle management for Intune managed devices. So yeah, let me start with the introduction. My name is Steven Behler. I'm a cloud engineer at glueckkanja, and I focus on automating and developing our managed Intune and managed Entra services. So these are services where we deploy Intune and Entra configuration as code. Then let me hand it over to Felix.
Yes, thank you, Stephen. I'm Felix. I'm a cloud engineer at glueckkanja in the team with in the workplace team with Stephen and Daniel. And yeah, my topics are managed Intune, Azure Virtual Desktop, and Windows 365. Daniel, would you like to go on?
Thank you, Felix. Yes, my name is Daniel Rum, and I'm also a cloud engineer at glueckkanja. I'm focusing on our managed Intune service, automating, reporting, and monitoring are my points. Yeah, Stephen, let's start.
Yeah, so just as a quick heads up, so if you have any questions after the webinar has ended, you can also hit us up on LinkedIn, write us a message, and we'll be happy to answer you also there. So then let's look at the agenda today. So first we're going to do a general introduction to PKI, then look at Microsoft Cloud PKI, its licensing and best practices, architecture and deployment models. Then of course it wouldn't be an Intune Suite webinar without a quick demo, so you can see how you can deploy it in Intune. And then we look at the use cases, and we also have a certificate-based network authentication slot, and then in the end the Q&A. So if you have any questions along the way, be sure to use the Q&A section here in the Teams meeting. You can write questions and we'll look to it that it's either answered during the webinar or in the end of it. Also a quick heads up. So there's a reason why we're doing this webinar. Last year, Microsoft announced that the Intune Suite is going to be integrated into the E5 license by June 2026. So in 2 weeks, it's pretty much around the corner. So we went through all of these features, and if you're interested, they're all uploaded, all webinars are uploaded to YouTube, and in general, our YouTube channel has a lot of interesting topics. So if you're also interested in Azure or security or workplace in general, you can find a lot of videos there. Then also a quick side note. So tomorrow there's another webinar, Enterprise Application Management. So if you haven't signed up yet, go to our website and you can sign up via our website there. So let me start with a general introduction. First, I want to look at PKI in general, because this is usually more of a infrastructure topic and less of a workplace topic. So let us just get a general understanding of what a public key infrastructure is. So a public key infrastructure, or PKI, is used to create certificates that prove that your identity is legitimate. And how this works is a certificate contains information. It has a private key, a public key, and a signature. And the signature is created using the private key and the information in the certificate. And then you can use the public key to verify or validate the signature. So only the owner of the private key can create a signature, but everyone can use the public key to validate if the certificate is true. So where this is used across the web, for instance, also for VPN authentication or Wi-Fi authentication, can also be used for email encryption, or in general for your enterprise infrastructure like servers. So you may be using certificates without knowing it on a daily basis. So a classic example, for example, is HTTPS. So if you access a website using a secure connection, the web server sends you a certificate, and your web browser validates the certificate with the internal trusted store. And if it's validated, if the signature is correct, then it will build up this secured connection. So now that we have a basic understanding, let's also talk about where PKIs were deployed until now. So usually you would deploy your PKI in an on-prem environment, and I allowed myself to have a little bit fun here with AI, and I generated this picture. So I think the AI nailed it pretty well. It's a dark, eerie room, a desperate IT technician trying to get the server up and running. Hardware was probably outdated. Backup, I think the AI put it pretty well here. We hope we have a backup. And I mean, at least, and that wasn't in my prompt, but at least the IT guy has some pizza left in the bottom left corner, so he can get through the weekend troubleshooting the server. So having your own on-prem environment has a lot of drawbacks. So it's a high operational effort. You need to constantly maintain and patch your servers. You need to lifecycle the hardware. You have the risk of outages. So if you have any issues with your CA, this may break the trust across many systems in your environment. And of course, the certificates also, since it is not automated, renewals and expirations need to be tracked. And this can also pose issues if you forget about renewing your certificates. It also doesn't scale well. So since this is in your internal network, you need a connection to your network. Without that, you don't get your certificates. So you can see this poses a lot of security challenges also. If your root CA, for instance, is compromised, then this will also break the trust across all of your devices. You also have the key person dependency. So usually you only have one or two guys that actually really understand how your PKI works. And if those guys are gone, then you're going to have a pretty bad day. Changes are also pretty slow. So let's say you need to lifecycle your server hardware, then you need to first order it. And usually it takes a few months till it's shipped. And this all generates new problems. And as I already stated before, the automation is pretty low on on-prem environments. You don't really have an API integration or anything similar. And for me, one of the biggest points is also the hidden cost. So even if you say, hey, we have this infrastructure, it's running, we have people that maintain it, you still need to invest time to build up expertise on how to maintain these PKI systems. So on the contrary, let's talk about the bright side. So how can it look like in the cloud? So also here I generated an image, the IT guy, happy, smiling. He has his dashboard where he can see exactly that everything is up and running. And he even has 2 cups of coffee. So he's having a pretty good day. So what are the advantages of having it in the cloud? So first of all, you don't need any infrastructure. It's all in the Microsoft cloud. So the backbone is there. It's scalable, it scales automatically. So if you get new users or you grow, then this is also not an issue because it's all handled in the background. You will see later in the demonstration, it is very fast deployed, so it doesn't take a lot of steps. It's a few clicks and then you already have it deployed. You also have the integration of Entra ID, so multi-factor authentication and conditional access policies. So you also really have a secure access to your certificate authority systems. And of course, since it's the Microsoft cloud, you have redundancy and high availability, which I think is close to impossible to replicate in your on-prem environment. And it's optimized for modern services. So it doesn't matter if you use mobiles or if you're working remote or you're a hybrid worker. Since it's over the cloud, you will get your certificates straight from the cloud and you don't need any connection to your internal network. So it's pretty secure by default. The global reach we already talked about. And I think this is also a good point. So you have a reduced operational risk since you don't have to set up all these servers and services yourself. It's all done automatically in the background. You also can reduce human errors. And I think this is one of the biggest points where, especially with certificate handling, it's important that you don't have any human errors in it. So let's talk a bit about Microsoft Cloud PKI in detail. So it's part of the Microsoft Intune Suite. You don't need any servers. It's all done on the Microsoft Cloud in the background. So you don't even need to access those servers. It's all automatically built up. You can access it via the Intune portal. So it's baked in there. No need for an additional administrative portal or anything like that. And it simplifies it really a lot. So it also automates lifecycle management of the certificates. And as you will see in the demo, it's really very simple. You can deploy it within a few clicks and get it up and running. And the cool thing is here also, it's supported on Windows, iOS, iPadOS, macOS, and Android. So it's really cross-platform. You have one trust chain across all those platforms. So it's one single pane of glass you have in Intune where your certificate authorities are, your registration authorities, your certificate lifecycle management, and also monitoring and reporting is also part of it. So now to talk a bit about licensing and best practices, I'll hand it over to Daniel.
Thank you, Stephen. Yeah, let's start with licensing. So any user which get a certificate through Cloud PKI from Intune needs to be a Cloud PKI license. You can get this license through the Microsoft Intune Suite or a standalone add-on, which need to be licensed for any user. Or like Stephen already mentioned, from June on, Cloud PKI will be included in the Microsoft 365 E5. So for everyone who owns this, it's basically just included. And also you can have a trial from Microsoft for up to 250 users for 90 days. And especially here, if you start with the trial, this will only be software-backed keys. And in the normal license, there will be hardware-backed keys. They cannot be migrated. So in the trial, you just test, pilot, whatever. And after that, if you want to go into production, you need to create them new. Yeah, let's go to the best practices and limitations. So basically, you start with, you will see it in the demo, you start with an root CA and with an issuing CA delivered from Microsoft itself. This is the easiest and best starting point. You can, or for any platform you have in your Intune, you start with a SCEP profile. Each platform needs its own SCEP profile. To secure the creation of the certificates and the SCEP profiles, you have the possibility to use the scope tags on any of this. And you also can build your own custom roles in Intune Airbag. And so if you, this I will also mention in the demo, if you start with the enhanced key usages in your root CA and issuing CA and in your SCEP profile, you need to plan carefully for which use case you want to use this certificate. Plan a little bit, maybe more, because the enhanced key usages cannot be edited afterwards. So if you need it more, you need to recreate it and redeploy it. So be careful. Yeah. Known limitations are so because they are hardware backed from Microsoft, you cannot export private keys. And we talk here only about SCEP profiles, and there's no PKCS support. And what else? Yeah, the Cloud PKI is an Intune Suite feature, and it's only owned for Intune enrolled devices. So you cannot deploy the certificates to other devices which are not Intune managed. So co-management and servers which are not in the Intune are not supported here. Also, we mentioned the platforms which are in support. Currently, Linux devices are not supported as well. Yeah, and maybe for them who has multi-tenant scenarios, there's no certificate authority sharing. So any Intune tenant needs their own Cloud PKI certificate authority. Yeah. Let's go to the next point. I think now it's Felix. Architecture and deployment models.
Thank you, Daniel. Yeah, let's have a look how Microsoft Cloud PKI is actually built. And yeah, on the next slide. Yeah, we go on. Yeah, the foundation is a two-tier CI hierarchy, a root CA and an issuing CA, both hosted in the cloud. The keys for both CAs are protected by hardware security modules. So we're talking about the same level of security you would expect from a well-run on-premises PKI. For certificate distribution, the service includes built-in certificate registration authority with an integrated SCEP endpoint. This is the part that replaces your on-premises NDES server. And CRL distribution, the revocation list, is also hosted in the cloud, which means you need no DMZ, no reverse proxy, nothing in your network perimeter. The whole thing integrates natively in Microsoft Entra ID and Intune. Now let us go on the through the diagram on the right. At the top, you can see the Microsoft Intune Admin Center. That's where an administrator set up the CA hierarchy once before any device enrollment happens. That's the B1 arrow going down into the Intune cloud. Inside the Intune cloud, you have three components. The Cloud PKI services, that's the actual issuing CA, the SCEP service, and the SCEP validation service. These three together replace everything you used to need on premises. Now let us follow the blue arrows on the left side. A1, the device checks in with the device check-in service. Intune knows this device is enrolled and managed. A2, the device sent its certificate signing request to the SCEP service. The private key is generated on the device and never leaves it. Only the CSR travels to the cloud. A3, the SCEP service forwards the request to the SCEP validation service, which verifies that the request comes from a managed device and that the SCEP challenge hasn't been tampered with. A4, if validation passes, the registration authority sends a request to issue the certificate to the Cloud PKI services, and the issuing CA signs it. A5, the signed certificate is delivered back to the device. Fully automated, no user interaction required. What you don't see in this diagram is exactly the point. No NDES server, no certificate connector, no DMZ infrastructure. Sorry, my Microsoft has moved all that into managed cloud components, and that's what makes its architecture so much simpler to operate. I need to drink some water. I'm a bit ill today. Let's have a look on the deployment models. The first model is a greenfield approach, and this is basically the fresh start. You build everything new directly in the cloud. Root CA, issuing CA, both are created and managed by Microsoft inside your Intune tenant. No on-premise servers needed at all. So this is perfect for organizations that are already fully in the cloud or anyone who wants just to have a clean start. Let me go through the diagram. On the top left, you see two certificates, the root CA certificate and the issuing CU certificate. These are created by Cloud PKI and everything else is based on them. In the middle, you have you have the trusted chain. This is what needs to get distributed to the right places. You also see private CA on the right. That's for any existing TLS certificates your network services are already using. That's separate and not coming from the Intune Cloud PKI. Now there are two paths going down. On the left side, the Intune MDM delivery channel. This is how your managed device gets its certificates. Intune automatically pushes the SCEP certificates and the SSL TLS trust certificate through the profiles. No manual work here, it just happens by itself. On the right side, this is the part where you have to do something manually. Your network services like Wi-Fi access points, VPN servers, web apps, they need to trust the Cloud PKI certificates too. But since they are not managed by Intune, you have to do some manually work. But in most cases, it's just a group policy object, so it's not that much work. And the main point is here for your Intune devices, everything is fully automatic. And the only thing you need to do care of is your network infrastructure. And here you can use, in the best case, GPUs. The next deployment model is the brownfield approach with bring your own CA. This one is for organizations that already have PKI running on premises, so you don't throw everything away. You keep your existing root CA, for example, an ADCS setup, and you just create a new cloud-based issuing CA in Intune that connects to it. Let us go through the diagram. At the top, you see the Microsoft Cloud PKI issuing CA certificate for Bring Your Own CA. This is a new Cloud CA that gets created in Intune. The important thing here is that it's signed by your existing private CA, so it fits into your existing trust structure. On the left, you have two things. The private CA certificate chain, that's your existing on-premise CA. And below, that's the new Intune Cloud PKI with Bring Your Own CA issuing CA certificate. Both of these go into the trusted chain in the middle. And on the left side, there's the Intune MDM delivery channel. Your managed devices get two things automatically through the Intune, the SSL TLS trust certificate and the SCEP certificate. But here the SCEP certificate is chained to your private PKI root CA. So the device trusts it because it knows existing your CA already. On the right side, there's your network services like Wi-Fi, VPN, web apps. And yeah, it's like on the other model, you have to take care of it and can create GPOs to push the certificate. And the last point on the side, both models can run at the same time in the same Intune tenant. So if you have some environments that are fully cloud and some that have still on-premises infrastructure, you can use it both in parallel. But one last note at this side. The first approach using the Cloud PKI is a recommend one. This ensures that you do not create dependencies on the local environment for the future. Yeah, I think we're going on with Daniel and the configuration steps.
Yeah, before we start with the demo, just the steps we will do now is we start with creating a root CA with all the configurations we can do there, and then afterwards we will create an issuing CA which is linked up to the root CA. And after this creation, we get the SCEP URI we need for the creation of the SCEP certificate profile. Before that, we need to deliver or deploy the trusted certificates through Intune profile. And in the SCEP profile, we just paste the SCEP URI we get from the issuing CA. And then we start looking I prepared something, how it looks on a client where a certificate is deployed. And let's go to the demo. I go and screen sharing in a moment. So I hope everyone can see something here. If I don't hear from my colleagues something negative, I think yes. Perfect. Yes, everything starts in the Intune portal and we will not leave it. And we go here under tenant administration. Before we start, under Intune add-ons, you can check if you already can configure the Cloud PKI under capabilities. Here on the downside at Cloud PKI, we can see here it's active for me. So basically, you need just one license in your tenant to start to configure this feature. And if done so, also you can see on the all add-ons, if you want to start a trial, you can go under Cloud PKI and go to the portal for purchasing the trial licenses. More up here is the Cloud PKI feature. Here everything will start. I prepared also here 2 certificates we will see on my test client, but for the demo we start creating 2 new certificates. So we give it a name and start with selecting the CA type. We start with the root CA here and selecting the validation we want. So for the demo, 5 years is absolutely okay for me. And the extended key usages, like I said before, you can choose here the EKUs you need for your deployment, and maybe on the root side, take a little bit more if you plan for the future. But for our use case here, I just think I take these 2 points. In this demo, we want to just deploy a device certificate with client auth, but I will show you in the issuing CA, we will see these 2 EKUs, and we can choose between, so we can limit it afterwards in the issuing and in the SCEP profile. And yeah, because if you create this root CA, you cannot edit it anymore. There's also another required field. It's a common name. So we give it a name. And the other fields are optional, so we don't need them in this case. And we can give here a key size. It's just an example, and take what you need. And we can start creating. At this point, we can also give a scope tag. We add one, and we can start creating. So now it is created, we can also download it. We need it for the trusted certificate profile to deploy it to the clients later on. So start the download. And now we can create the issuing CA. Here we need to take the type issuing CA and need to link it to the root CA we also already created. Here also you could use the bring your own root CA, but this is in this demo not what we're focusing on. We just took Intune here as part and take the root CA we already created. We want to link it to the webcast root. Afterwards, we also give the validation period. I took 5 years in my root CA, so I cannot choose between 10 to 2 years. It needs to be under the 5 years, so I take here 2 years, is okay for me. And I can choose between the EKUs the root CA already have, and cannot add in the issuing CA more of these ones. So in this case, I just take the client off, and for example, you could have a second issuing CA, which is also linked to the root CA, which has maybe just the EKU for server auth or whatever. Take also here the common name I want, and just press next, next. Great. Now it is created. We can also go here, the properties, we can download the certificate. And later on, we need the SCEP URI to be pasted into the SCEP profile. So I will copy it right now, use it later. So now we created these 2 new certificates. Let's go to the devices. You need it for any platform you want to deploy these certificates. In this case, we will do it only for Windows. The Windows configuration. Create new policy. Windows 10 and later. Profile type is here templates. There's from Microsoft trusted certificate template, which you can choose. And you just press create, give it a name, whatever your naming convention is. start here also with the root. I'll take the root certificate, which I created already. Take the store where it should be published. Here we need a root store. Go next. Can give a scope tag. And of course, for testing, piloting, or focusing just on a group of devices which are maybe licensed, you can choose a add group here. Because I'm just in a demo tenant, because it's easier, I add all devices, but be sure if you add here every device or all devices, all Windows devices will get the certificate. So, and just great. The same thing we will do for the issuing certificate. Take the file I downloaded. And here in the store, we take the intermediate one. Next, next. Assign again to all devices. Yes, so now we published or deployed or created the profiles for the deployment for the root and for the issuing CA to the devices. Now we can go on and create the SCEP profile. There's also a template here from Microsoft. Just called SCEP certificate. Go to create. Create the profile. And for the demo use case, absolutely, you need to figure out what you want to establish with this certificate, but I make it here really straightforward. So we just take the fields which are required, the subject name. You can here take the subject name from the Android device ID. You also can, there are a couple other possibilities. You can also publish the subject name as the host name of the device, but this is more identified for the device, I think. So take this one. You can choose here between the validation period for this certificate. After 1 year, it will be renewed, but you can also go on months or days or whatever. The key storage provider recommended is here the TPM SCEP. Otherwise it fails, so only devices with TPM, because I have here a lot of VMs without TPM. Just in my case, I take this property. But here we need to use this key usages and configure the key size byte. But it's at the end, you need to figure out what is here important for you. Now, as we created the root CA trusted certificate profile, we need to link it, the SCEP profile, to the root CA. And this was this one. And also the key usages. And here we just can use the key usages, which we have already added in the root or issuing CA. Here's also a renewal threshold. So if the certificate has a validation period of 365 days, and we took here 20%, it's about 73 days. After you hit this mark, it will start to renew if the device checks into Intune. Here we will add the SCEP URI we copied from the issuing CA. And go next, next. Deploy it here also to all devices. So if you pilot or whatever, use the add groups and add a group with devices in it. So now we created all the profiles. You can check it here. Now we see them. For my testing, I created before the SCEP profile. We have 3 possible places in Intune where we can see which certificates are deployed to monitor the deployment. One is we can go to the SCEP profile, and here's a third point you maybe don't saw really often in your Intune portal. The most people know the device assignment status, so if the profile was assigned, but if a certificate was really deployed to the device, you can see here. So here you have all the overview about this SCEP profile, which devices got a certificate. Another good point is under devices, monitor certificates. Here you have the option to see any device from any SCEP profile, from any platform, which got a certificate deployed, from which issuer, so which issuing CA deployed here certificate, and you can also export it to a CSV. And in tenant administration, under Cloud PKI, in the issuing CA, you can view exactly the certificates which has deployed a certificate, and also you have the option here to revoke a certificate, which I have done here, for example, and this will then be removed. So on a device which got a certificate through a SCEP profile, you can also go in the local certificate store, and here you have all certificates which are stored in the local computer store of certificates. And if you go under personal, I delivered this one from the test issuing CA, and here you see exactly the certification chain. So I got one for my PC, it's issued by this one, and this is chained to the root CA. Also, you can see under trusted root certification authorities, the 2 certificates I already deployed through the trusted certificates profiles. Yes, and that's mostly all about how to deliver or to deploy a certificate through Cloud PKI. Steven, maybe you want to show us some use cases. Now we have the certificate.
Yes, definitely. Let me just get the presentation up and running again. So thank you for the demonstration, Daniel. So yeah, let us talk about the use cases. So first I want to talk about what Cloud PKI is not. And especially since I saw already questions in the Q&A section, I think it's important to clarify this. So Cloud PKI is really targeted to Intune managed devices. It is not a full-featured enterprise CA replacement. So depending on your use case, you will not be able to use it. It really depends on if you're talking about Intune managed devices or not. So let me go into a bit more detail here. So it doesn't have the full feature parity with Active Directory, certificate authority / certificate services. So for example, you can't deploy server certificates because your servers are not enrolled into Intune. So web servers, load balancers, VPN gateways, application servers, this doesn't work. So you can't get a server certificate because the server is simply not enrolled into Intune. And then also, of course, this goes hand in hand. So if you have devices like, for example, Linux devices that are not managed via Intune, then also here you won't be able to deploy the certificate to the device because they are not in Intune. You also don't have things like role-based rules that you can define in the certificates, which is possible on Active Directory certificate services. And I think this is the most obvious. So it's not an offline PKI. So if you have an air-gapped system, if you have very sensitive information that you don't want in the cloud, then of course this is also not possible. And this goes also hand in hand. So Entra ID and Intune are the key dependency here. So you need Entra ID, you need Intune, because as you saw in Daniel's demo, it is all managed right in the Intune portal with your Entra ID. So now that we got out of the way what Cloud PKI is not, let's talk about the actual use cases. So as I mentioned, it is really meant for your Intune managed devices and identities, so that you have a cross-platform device identity across Windows, iOS, iPadOS, macOS, and Android, as mentioned before. And you can use it, for instance, for client authentication, also in your internal apps. So to check your client certificate and like that, authenticate to those apps. You can also use it as VPN authentication. Also here, you use the certificate to authenticate against your always-on VPN or also third-party clients. So your user doesn't have to type in their credentials every time. You can also use it for port-based authentication on managed LAN switches. So if you have a network that requires this, that you authenticate to the port, you can also use your certificates for this. And another use case is Windows Hello for Business Hybrid Cert Trust. So this is used if you have cloud-only devices and you want to access on-prem resources, for instance, let's say a file share, and you need to authenticate somehow. So instead of having the user to type in the credentials, you can also use here certificates. But one side note here, we would definitely recommend using Cloud Kerberos Trust for this scenario, just because it's a little bit more modern approach using your tokens and you don't have to rely on the certificates. And then last, but definitely not least, also Wi-Fi authentication. So instead of deploying your Wi-Fi password, which may be subject to change via an Intune profile, you can also do this with certificates. So you put the root certificate on your Radius server and you use client authentication to authenticate to this. And for this today, we have a special guest. So Stefan Schönleber of the products team will show you a little bit more about Radius as a service and how it integrates into Microsoft Cloud PKI. Hello, Stefan.
Thank you, Stephen. Yeah, thank you guys for having me. And as Stephen already said, I'm a special guest today, and we want to look a little bit deeper into this, most probably most important use case for client certificates. It's the network authentication done by certificates or done through certificates. And what we have a PKI, we have certificates on the client, that's nice. And now the question is, how can we authenticate to the network using or leveraging the certificates? What we need is a Radius service. In the past, you were maybe using NPS, Network Policy Server. It was working fine. The main thing here is NPS relies on the objects or the identities to be present in the local AD. And this may be an issue for cloud-only identities or devices. That's where our Radius as a service comes into play. And you see here in this architectural overview how this fits in. On the right side, you see the Cloud PKI. And we already saw in the demo how you issue certificates using Cloud PKI. This is the arrow at the bottom with the SCEP naming on it. So that's how you issue certificates. So let's assume we have the certificates on the client. What do we need now to authenticate to the network? So on the left side, we see the clients, and the clients are talking EAP to the network components, and now the network components need a Radius service to do the authentication and to look up, okay, is this certificate that I get here through EAP, is that from a person I want to let in, or from a device I want to let in? And yeah, we use the RADIUS protocol to do this authentication. Actually, we prefer RADSec, which is the more modern approach for RADIUS. So RADSec is basically the TLS version of RADIUS. It's more modern, but it's quite some days, and most of the network infrastructure vendors support it nowadays. So if you have it available, we highly recommend to use that one. It has one big advantage besides the security. It is TCP based, which gives you more reliability while using it. So when we now use this RADIUS protocol, what will RADIUS as a service do? RADIUS as a service will have a look at the certificate and will now evaluate, okay, is this certificate a certificate that I trust? Is it still valid? We also have a comprehensive rule engine where we may process rules like having filters for access points or whatever. And then additionally, RADIUS as a service will also check for the revocation. Daniel showed before how to manually revoke a certificate through Cloud PKI, and how does RADIUS as a service get knowledge of this? The Intune Cloud PKI publishes a CRL, and we are leveraging that CRL to double check if the certificate is revoked or not. And once this is done, RADIUS as a service will confirm and will let the user into the network. So that's generally the architecture and how things are playing together. Let's have a short look on the next slides, how you set it up. We will not demo this, but just give you a very brief run through. It's not a big deal. There are four main steps. The first step is RADIUS as a service has to trust Cloud PKI. You do that by uploading the root certificate of the Cloud PKI to the RADIUS as a service portal. The second thing is the clients need to trust RADIUS as a service. Every RADIUS service has a server certificate. RADIUS as a service offers an own server certificate that comes with the service. Since Cloud PKI cannot issue a server certificate, so you need to deploy the RADIUS as a service route to the clients. It's the same mechanism as we saw before, deploying the root certificate of the Cloud PKI to the clients. The third step is to set the network equipment to use RADIUS as a service, which basically means you would go into your network equipment configuration and configure the RADIUS part there and point it to the IP addresses that come with your RADIUS as a service tenant. And the fourth step now is to let the clients know how to use the Wi-Fi, and basically this is about configuring an Intune network profile or Wi-Fi profile, which defines which Wi-Fi to use, which defines which certificates to use. You will there point to the SCEP profile or to the SCEP certificates that you have been configuring before, and this network profiles basically tells the client, okay, which certificate to use for which network and which network to trust. And once you've done that, and I think that's the main goal we have when using network authentication with certificates, we want to get really a seamless experience for the user, which is you as an administrator configure everything in Intune, certificates, network profile, and so on, and the user just uses it, and with no user interaction, they automatically join the Wi-Fi and use the service. That's the main goal, and this is really that's what you get when using this technology, and it's really nice. So no credentials, nothing, no network to trust. The user has no work here, just using it. Last but not least, if you are interested, of course, RADIUS as a service is our solution we offer here. As an addition to Cloud PKI, we offer a free trial for 30 days. No credit card required, and there's also no sales call if you don't want it. Just check it out. And maybe last but not least, you heard about the scenarios that are not supported by Microsoft Cloud PKI, server certificates or non-Intune managed clients. This is something where SCEPman, which is our full-blown PKI, can help to add on to Microsoft Cloud PKI. If you're interested in that, also feel free to reach out. We are happy to help. That's it for me, and I'm now handing back over to Felix.
Yeah, thank you, Stefan. And with that, we've reached the end of today's session. Thank you for joining us. We hope you got some nice insights into Cloud PKI. And if you have any questions, please use the Q&A section right now. We're happy to help you. And yeah, if you have something later, some questions later, you can reach out us via LinkedIn or mail. And yeah, we are always happy to help you. And thanks again, and have a nice day.
Yeah, thanks. So hey, maybe we just look through the Q&A real quick. So I can see that there are a few questions. One I want to, for instance, quickly also talk about is about licensing. So what is important is if you have you only need one E5 license for Cloud PKI to be enabled, but for you to be compliant with Microsoft's licensing agreements, you really need a license per user. So that's really important, and it's with a lot of Intune Suite features like that, that it is activated from one license. But if Microsoft doesn't audit and you don't comply with the amount of licenses and users that are using it, then you will definitely have issues. So be sure to definitely look at that that you are covering that correctly. So maybe another question that was also already answered is if there is a like a limit to the amount of CAs that you can deploy with Microsoft Cloud PKI. So the limitation is 6 CAs. So it's not limitless, but in those CAs, the amount of certificates is there. It is limitless. So it doesn't matter if you have 10 devices or 100,000 devices. As long as you don't deploy more than 6 CAs, this shouldn't be an issue.
There's another question: who can set up the Cloud PKI? Yeah, only the global admin or Intune admin, both can do it, and you can configure a custom airbag rule if you want a user which is not Intune admin or a global admin, which should be creating the CAs or the profiles. You can establish, you can get it through the Intune roles. But yeah, global admin and Intune admin is for the first time, right?
There may be also just as another heads up. So this webinar is going to be uploaded to YouTube. So if you want to rewatch the configuring steps, you will find it there soon. Okay, so there aren't any new questions. So I hope you enjoyed the webinar, and thanks again for watching. And then, yeah, have a nice rest of the day.
Have a nice day. Bye-bye.
Bye-bye.
Bye-bye.